in the evening? Are you planning in the evening?
I'm not sure if there are such, then surely you people have informed. I have to ask. I have to ask while going to the last. I will surely try to ask you. So I will ask and inform you what will happen.
Okay, sir.
Just 1 minute, yeah.
The voice is not very low.
With mine?
Is it loud now? Is it okay now? My voice is.
Yes, sir. Yes, yes.
And yes, for the special session on first variable, yeah, today
Yes.
will happen. Yeah, Subhasis will take that session.
When, sir?
Subhasis.
When?
Okay. 1 minute
We
later.
had told that today or Friday we will take it. So at what time? In the evening, I think most probably in the evening.
Sir, evening, please don't take any session because today is a festival, so maybe.
Boss, I'm not saying this. What they had.
Sir, actually, sir, we can have this special session after Sunday, sir.
Sir.
Yes, sir, that is also fine. That is also fine. Yes.
Today it
Krishna
doesn't make much sense today.
No, I am just asking Krishna Mohan. I am not saying to have it there. I am just asking what happened to that. I am requesting it on behalf of everyone.
There is a festival, so.
Yes.
More than festival, from my perspective, is that.
And we have exam also, no? On Sunday we have exam also.
Yeah.
Okay, so maybe possibly today will happen, and that is discussed 1 week before. So let's see that. Yeah, today will. I'm looking that they are asking will the session will happen. Let's see. At the end, I will surely tell you timing. Also, I have asked and link whatever the things are there. Okay, so today's session is a kind of open session and solve it also. You can think at. I have some question for you, and we can go with your doubts also. So let me show my page here. So this is for like solve with us, and in between you can ask your doubt also. And before that, like let's solve this first question. After solving or after solving this, I will take your doubt or activity anywhere from anywhere, and then move on to the next question. Like that will happen. So this is the first question. You can try this. Hope my voice is loud and clear. Is it?
Yes, sir. Yes, sir.
Yeah, thank you. So you can do with this question. So, and this question is from week 10, and this session is also for week 10. So which option is going to be answer, or there is no option and no correct matches? Is that happening or anything? All of you are solving, right?
Yes.
Okay. So one thing, why this equation or equation of line, actually whatever the options are there, or a tangent line, line in 3D, in 2D, you know, in R2 is kind of relation in X and Y, that's all. But in when you come in R3, you need a kind of parametric equation, like here it is, this is called symmetric kind of something. So why such kind of is needed? If you like, the reason is, if you write a relation between X, Y, and Z, that is shows a plane, not a line. So you can differ with this one, that uh, representing a line can be writing like this in the equation form of xt, yt, and zt kind of, where t can be a real number. So no one is, I don't know, no one is posting this. This is the direct question. There is no differences, just changes in some function. Like this is the direct to the video lecture. Just need to remember the formula for tangent line. Let me write also. So
sir, in case of single variable, it will be dA by dx, but here it's two variables, right? So it's like three, sorry.
oh, okay.
X and y, sorry, X and y, that is,
So what is the writing to be the equation of a tangent line is xt will be, let's say we have a function, and at point AB we want to find a tangent line in direction of, let's say, u1 and u2. Then the equation of tangent line will be a plus u1 time or t time u1, xt will be, yt will be b plus the direction multiply, t will be multiply with the second coordinate, or yeah, this need to be unit vector first. This should be unit vector. I am assuming this is a unit vector, but the question is, this is not in unit vector, so you have to change it in the unit vector. And the zt will be your f of ab plus directional derivative. Let's say this is u, this direction is saying to be u, directional derivative, the direction of u at point AB. So, and times t. So this is the formula for writing the tangent line. Now you can tell me what will be the, which option is going to be true.
One, sir.
One.
But sir, I'm getting z of t as 1 plus t by root 2.
Z is equal to,
Option 3 is true. True.
Yes, sir. Option 3. Option 3 will be.
Option 3. No, option 3 is also.
Option 3 is true.
so okay. So option 3 is, many of you are saying option 3. So let's evaluate that. What will be the equation of line? I'm looking some what he says in chat, that where did z come from, sir? So when you see your this equation, when you graph this function, it's needed 3 dimension. That means x-axis, y-axis, and z-axis. So tangent is saying to be tangent line on the graph of the function. So in that, see, the graph of the function line in 3 dimension. So to representing a line in equation form, in R3 you needed 3 axes, right? X and Y and Z. That's why here came xt, yt, and zt. Okay. So let's evaluate that. So this
Or
direction
we
is
can, yes, sir. So, or we can actually take the function f of xy as z actually, I guess.
yeah, that's the main also.
Thank you.
Actually saying that's the meaning of
And
graph. If you have a, like, suppose you have a function with this, let's say this one. So what this portion says, if you graph this function, you needed 2 dimension, because this is of one variable. So when you graph this will work as a y-axis or value
Yes.
of y.
Yes, yes.
Similarly here, there are 2 variables. You can think these are x. This x from values come from x-axis, y values come from y-axis, and this portion represent your z values when you
Yes.
graph the function.
Yes.
That's why.
Yes.
And when you graph this function tangent line, if you draw in R3, so you needed 3 coordinates. So that's why you need to be like x-axis, xt, yt, and zt, you can say.
Yes.
So let's see, you have the direction this one, so you have to change this in univector. So how you will change? You will divide with the norm. So norm will be a coordinate y, taking the square of coordinates each each coordinate, like x-axis, whatever the value in x coordinate and y coordinate, and divide with that. So this will be, so this is unit, you can say direction. You in this direction, unit vector is this. So now let's write the equation as I have written above the formula. A means saying to be this s minus this x coordinate value. So this is -1 plus t time this u1 as here. Let me show you this one as here. U1 is your this one. Yt will be second value, as here is 1. So 1 plus t time u2. So u2 is again saying to be 1 upon root 2. Now zt is value at ab, means saying to be value of what will be the value at -1 and 1. It will be 1 plus 1 minus 1. So it will be 1 here. So the value at -1 1 will be 1. And directional derivative now need to be evaluated. So how we will evaluate the directional derivative? You have 2 ways. First is using the algebraic definition or limit definition, you can say. And second is take the gradient of that function and then multiply with the take the dot product with the direction whatever you have. Means first is take the gradient of that function. It will be del of this one, partial derivative with respect to x and y. So this is 2xy plus 1 with respect to y will be what it means is you can think y as a constant here and derivate with respect to x. Now when the second case is here, so you will think x as a constant and y as a variable and derivate to this function. So it will be here x square
+1.
plus 1. Now gradient of function at -1 1 will be 2 minus 2 plus 1, and this is 1 plus 1. So this is -1 2. Now what will be the then directional derivative at 1 1 in direction of
Unit vector of 1, 1.
unit vector of this. So it will be taking to be the dot product with this unit vector. So it will be 1 upon root 2. So now zt will be directionality time directional derivative and directional derivative of the function, which is 1 upon root 2. 1 upon root 2. So the equation of tangent line will be this one. Hope is it clear?
Yes, sir.
Okay. You have doubt here? Anything?
The last portion I couldn't.
Just the dot product parts. So the
Just why
derivative, sorry,
This
the
portion, sir.
gradient is minus 1. Sorry, we are out in the
Gradient is 1 here. Oh, taking the dot product is what will be the dot product? So this will be multiply with this and this.
No, that I know, sir. What I was asking is
Huh.
the gradient. Gradient at -1 we have calculated,
Huh.
and the dot product is done because what is the reason? Like in the direction of I didn't get that, like the direction of the vector u1 is it or
Okay.
no, what I was asking is the dot product is why are we doing the dot product here?
So yeah, actually in video lecture, the first thing is taking, that's why I said there are two ways. First thing is you can go with this method to getting the directional derivative, or the second way is taking limit, that is called limit definition, saying to be limit h tending to 0, directional derivative in the direction of this one is at point whatever the given, so point is here, plus directional derivative is writing to be 1 upon this one, the direction, minus
That
f
one
of
is quite complicated. And the first dot product one is quite looks relatively easy. So why are we taking the dot product? That is in the direction of the unit vector. Is that the one?
Is that one? No. So why this is equal to this one, you are asking?
Yeah, I'm just asking why are we taking the dot product of -1 and 2 with 1 and
yeah, simply like you can think as a remember now, otherwise there are some different institution how why it came. I think sir have told you in video lecture how it's these two are equal, but no matter, saying to be in a question asked for the directional derivative in the direction is given at such at a particular point, you can go with this one. Suppose you have a complicated function like this, then you have to go with the definition, like let's say this is xy upon x square plus y square when xy not equal to 0 and 0 when xy equal to 0. In such cases, asking for directional derivative at 0, it will be difficult to evaluate with this method. Then you need to be evaluate with this method. So that's why you can say two definition, and these two are equal. There is I will say no need of go with the this is intrinsic or inside of this. You can think as a definition also, and you can go with it. Otherwise, I have to check for why these two are equal. And actually, I can tell you here also, but that is a long process to telling why these two are equal. Is it clear, or I don't know?
yes, sir. Yes, thank you.
Yeah. Otherwise, I can tell you here in this definition you can evaluate this one. Like you can find why it's happening using this definition. But that is a long process to saying to getting that. So no issue. So I hope now it's clear to all of you, or you go with the just formula. There is no person. There will be no question like asking why these two are equal, why such kind is happening. This is you have to go with the to know that you have to go with your textbook. Okay. So now you can ask your if you have doubts from activity or any practice or conceptual. We can discuss those and then we will move on to the next question. Yeah.
So activity 10.1 question 8.
Okay. 10.1. Question 8. Okay.
So in this question, is f of x comma y comma z equals to minus f 5x possible?
Minus 5x. Okay, so
Yes, sir.
it can.
Okay, sir.
It can. Why? Because okay, just 1 minute. Because magnitude will yeah, the magnitude will be the same, and yeah, it can be.
Okay, sir. So then I have doubt from 20.2. So question number 1.
Okay.
So can you solve this one?
Okay, so this question is for asking a continuity of derivative at origin, a partial derivative at origin. So you have to always go to with the definition. Okay, let me check once. So you have function x squared sine 1 by x plus y. This is the case when x not equal to 0 and 0 when x is equal to 0. So partial derivative with respect to x will be limit h tending to 0 f of at 0. It will be h0 minus, okay, let me write the definition first. Okay. Just 1 minute. So definition is saying this will be f at 0 will be 0 0 plus h10 okay, minus value at 0 upon h, okay, and so it will be limit h tending to 0 f of h0 and 0 at 0 will be 0 minus 0 upon h. So this is x square sine 1 by x. So here it will be h square sine 1 by h upon h, and this limit when h goes to 0.
Goes to 0.
This is h sine 1. This will be 0.
Yes.
Yes, sir.
So
Yes, sir.
yeah, so reason is you can change this sine 1 by h upon 1 by h. So the case is you can evaluate, or you can bound this one, and this is bounded and this goes to 0. The second way, this is goes to 0 and sine function is bounded. So you can use here sandwich theorem to decide that this limit is 0. Now but we want to check, we got value derivative at 0 0, but we want to check the
Sorry,
hmm,
sir, Guru, x tends to 0, sin x by x is 1, right?
sine
X tends to 0, sin
Hmm.
x by x is 1, right?
Oh, so yeah, when limit x goes to 0, sine x by x is 1.
Yes, sir.
But here is not case. Here 1 by h. Here 1 by h is here.
No problem. 1 by h by 1 by h.
So no. So here is the case when x is goes to 0. This inside portion goes to 0. This one goes to 0. But you check. I change this function to here. When h is goes to 0, this goes to infinity. This also goes to infinity. Not the same. Not the similar case is here. So that's why limit is different.
Okay.
Okay. So now we want to check continuity. So you have to again see, this is the way to getting derivative, partial derivative at 0, 0. Assuming to be we want to check the continuity. So that what it means that assuming to be x not equal to 0 and just try to get the partial derivative with respect to x. So assuming to be not equal to 0, so you can directly derivate it here. So what we then, this be like saying to be derivative of this one, this will become 0 with respect to x. So it will be like here is a product rule apply. So here it is 2x sine 1 by x plus x square as a derivative of cos x, sine x will be cos 1 by x. Now next
And
is inside
minus 1 by x square.
minus 1 by x square. So this will be 2x sine 1 by x minus
Cos 1 by x.
cos 1 by x. So this is your partial derivative assuming to be x not equal to 0. So now you have to check, is it continuous? So you have value that at 0, 0, you have already evaluated. This is at 0, 0 is 0. Now let's check when x y goes to 0, because we want to check at origin. When xy goes to 0, f of x, we have function is x y goes to 0, 0. Your function is 2x sine 1 by x minus cos 1 by x. So there is no y, so you can remove this y and think as only x goes to 0. So this is, you can, this we have like a single variable. So what will be the limit here? As x goes to 0, it
Sir,
will
it doesn't
separated here.
exist.
It will separated here. So when you separate here, it will be, this will go to again 0, and this is as x goes to 0, what will be this limit?
Sir, it
This
doesn't
limit is
exist.
not exist. So finally you can say limit at 0, 0 is not exist. So this function is fx is not continuous here. Like sorry, partial derivative with respect to x is not continuous. Similarly, you can check for y. So if you check for y, what's happening, Preetham, here for y?
Sir,
Will
it's
be
not continuous.
continuous, I think.
It will be continuous. It will, when you derivate with respect to
We'll
y,
get one.
it will be 1 here and this is 0. So it will be continuous at origin. So is that any issue in question?
Sir, it won't be continuous, sir.
Constant function is continuous.
Yes, sir. It won't be continuous.
No, fy will not continuous.
Yes, sir.
Okay, okay, let's check that. Okay, okay.
So we
let's-
can see it from here. If we take x not
okay.
equal to 0, then we get fy as 1.
Okay,
And if we take x equal to 0, then it is 0.
okay. So okay, so fy will be 1 here. Okay, and when limit x okay, fy will be 1 here, and you take value of the function fy at 0, 0, what will be limit h tend, okay, the problem is here. Okay, yeah, so this will be f of 0, 0 plus h times 0, 1 minus value at 0, 0 upon h. So this is not exist. The value at the partial derivative at 0, 0 is the problem, is right? So it will be limit h tending to 0, f of 0 h.
No, sir, it will be 0.
It will be 0. Yeah, it's coming to 0. Sorry. So it will be here. So this is 0. So limit h tending to 0 and 0 minus 0 upon h, which is 0. So the case is here, what's happening when you are getting this at 0, 0, this is 1, and you can say limit xy goes to 0, f of y, this is 1. This is 0 and this is 1. So function value at 0, 0, and when you are taking the limit value, this should equal to 0, then we will say a function, then we will say this is continuous. What is the case here? Xy goes to 0, f of y should equal to f of y 0, 0. But the problem is happening here. So that's why, okay, yeah, I missed that. Yeah, that's why I need to be go with the definition will be more proper way. So is it clear or
Yes, sir. Clear.
okay? Yeah, I just look while looking, I said it is continuous, but yeah, when we go with the proper definition, see, it's looking like here is continuity happen. When we go with the definition, the problem will, you will see that why it is not continuous. So what we discussed here, is it clear to all of you, or please let me know if you have issue while solving or getting what's happening. Okay. Okay, so no issue. So let's move to be the next question.
So question 2, option 2.
Question 2, option 2 here.
So what does that mean?
A tangent line at origin do not lie on a plane. So it's mean to say a tangent line.
So
See,
does that mean that the tangent hyperplane doesn't exist?
no. Does it does not lie in a plane means yeah. So not exactly on the tangent or hyperplane. So going to be any plane here. Any plane, not lie on a plane means not line in any plane. See, if you there is a line, you can draw a plane like this. Surely that the thing is, if there is a line, you can draw a plane. The full line will be lie on that plane. There is no case. So it need not be hyper or you can tangent plane. It need not. It's not asking for the exactly tangent plane. Differ plane also.
So sir, if at the origin, suppose all the tangent line exists, then there is only there's a unique plane that encompasses all of these tangent lines, right?
Yeah. So the thing is, if yeah, okay.
And which
Continue.
is the tangent hyperplane?
Tangent hyper. When the condition is when we will say there is a tangent hyperplane when all tangents lie in a unique plane. All possible.
Yes, sir. So here it's given that the tangent line at the origin do not lie on a plane.
Still there is a problem. If all tangent line lie in a plane, still there is a problem. We cannot confirm that tangent plane is exist. But reversely is that if tangent plane is exist, then all tangent line will lie in that plane. We are sufficient the word with if tangent plane is exist, then all tangent line will lie in that plane. But the condition is if all tangent line is exist, still we cannot say it will lie in a unique plane. So reversely we can go, but not this side. Okay, that is a different matter. Yeah, you are asking for different. What is that?
So 1 minute. So basically, we can say if a tangent hyperplane exists, then all tangents at that point will lie on that plane, right?
Exist and lie on that plane.
Okay, sir. So what is the contrapositive of it? That if the tangent lines are not lying on a plane, then the tangent hyperplane would not exist, right?
Would not exist. Okay. Would not exist. We can say, yeah, but
Yeah.
not. It is not always the case. But it can or it cannot also. But surety is when the plane is exist, then always all tangent line will exist in that plane. If you are at that point we are taking.
So basically, I'm looking these statements as A and B. A is the statement that the tangent hyperplane exists. B is the statement. All tangents lie on that hyperplane. So A implies B, right?
A implies B. Yeah.
And the contrapositive would be B complement implies A complement.
May not be. May not be also.
Why, sir?
I'm
This,
not sure. I have to check for that. I'm not sure, but may not be. May not also, because the reason is when you go with the differentiability, see, the condition is you can always derivate and try to get a partial derivative, but there is in the video lecture there is a sufficient condition sir have said. So you have, sir, in the video sir said all partial derivative exist, then you can easily get the tangent line. But the when tangent plane is saying to be exist, means at that point the function is differentiable, and the differentiability condition needed more things. In that video has sir have said, that's why you cannot directly say if tangent plane is exist, then fine. But all tangent line exists, still the condition is tangent plane may not exist, may not be. Because of that, more it's needed more sufficient condition, and I have to check for that, is that possible or not. But I am sure may not also.
okay, so then I would need you to solve this question.
Mhm. Yeah, but it will take time. I have to go with my textbook. Yeah, because this is a very crucial thing. Crucial, make more knowledge. What are the sufficient condition for existence of tangent plane? Yeah.
Sir, not that one. I'm talking about the activity question.
Okay. Okay. For this one.
Yes, sir. I was thinking that from that statement we can conclude that the tangent lines will not lie in the origin if we get that the tangent hyperplane does not exist. But if that is not the case, then I don't know how to solve it.
So here is simply asking that a tangent line at origin do not line on a plane. It plane is saying to be it may not, it may or may not also tangent plane. Asking for different plane also. What it mean? What I
Yes,
am
sir.
saying. So suppose this is the tangent line for this function. So let's say this is the line. So the plane can be like this, containing this, or still it can be it cannot be a tangent line. Just 1 minute. It cannot contain this tangent line. So actually that plane may or may not be see, there can be a tangent plane. Let me give an example. Okay, suppose this is the line and this is the plane here containing that line. So that plane is okay. So here the plane is for asking any plane means to be a tangent plane, because when it will okay. So okay, tangent line at origin do not lie on a plane. Okay, so yeah, the case is here. So asking for that plane is saying to be a tangent plane. Yeah, then it will possible. But there is a possibility that uh, suppose you are able to get a tangent line at that point, but you may not get a tangent plane at that point. For that I have to check for, because but there is a possibility, there is not possibility, there are this will not make a sufficient condition that there is a tangent line, then the tangent plane will exist at that point. Reason is, let me tell you, I am giving to you an example. F of x y, let's say Okay, I'm not getting, actually mean to say that in this direction you are able to get a tangent line, okay, but not exactly the plane, because plane is asking, suppose I asked the tangent line, suppose I asked the tangent line in this direction, and suppose partial derivative or directional derivative in this direction is not exist, but tangent plane, the plane containing this line means this contain all possible direction, right? There is a possibility, I'm this time I'm not getting, there is a possibility. Pritam, am I audible?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
So what I mean to say, suppose in this direction I am able to get a line,
So
tangent line,
basically,
suppose, and
the tangent hyperplane which we
in
get is that contingent upon the directional derivative, basically a particular direction.
tangent plane, yeah, for tangent line we need a direction, but for tangent plane we don't need direction. It will mean saying to be it contain all direction,
Yes,
uh,
sir.
mean to say tangent plane contain all tangent lines in all direction.
Yes, sir. Yes, sir.
So suppose you are able to get tangent line in this direction, but tangent line in direction may not exist in this direction, in different direction. And then how you could say, then plane, when you talk about the plane, so suppose this plane contain this line, so what it mean that like in a small portion of this line it will contain this plane also, right, this line also.
Yes, sir.
So it may not, that's why it may not.
Okay, sir.
But exactly I'm not getting the exact function. Yeah, there is a way, I have to check that function is, okay, I will post in discourse this. I will give you
Okay, sir.
I will give you. Okay.
So then can you go back to the question?
Okay.
So here the partial derivatives are constants. So in this case, tangent hyperplane would exist.
Yeah, here the partial derivative is constant. Tangent hyperplane is exist.
Yes, sir.
Okay. This still the condition is may not be, may not be also. If you will use directly formula, you will say, okay, yeah, like what is the formula for tangent plane is
F of a
directly to be putting the partial derivative. If
Yes,
such
sir.
thing is happening,
Yes,
then
sir.
we can say, yeah, tangent, we are able to get the tangent plane.
Yes, sir.
But there are such condition where the function is not differentiable, but you are able to get the, there you are able to get the partial derivative at that point. So that's why it's needed, like, see, you are able to freely use this formula when function is differentiable at that point. Suppose
So here, partial derivative in both side x direction and y direction is constant. Then from that we can say that function is continuous. And function is continuous, then at any point, and if a limit exists and unique, then we can say that the tangent line exists in all direction, and then tangent plane exists actually at that point.
No, your the same function is here, right? Just now we discussed about this function, f of x, f of xy is equal to x square sine 1 by x plus 1 by y, sorry. Partial derivative for this function is going to be constant, but with respect to y only for this function, there may be possibility for x also, but the function is, see, for the function partial derivative here we know that not continuous. So how it could be differentiable? when it is not continuous at origin, so how it could be differentiable? So this formula is actually performed better when your function is like a polynomial or a differentiable. When your function is differentiable, suppose your function is not differentiable at that point, then you will not say that the tangent plane exists at that point, because your function is not differentiable. And tangent, if tangent is exist, means saying to be differentiable. So partial derivative can exist, but you cannot say the tangent plane is exist. So this question is true for the differentiable. This formula is true for the differentiable function, but not for differentiable function.
Okay, sir. Okay.
Pritam, are you getting that what I'm saying?
Yes, sir. Yes, sir. Sir, please show the question.
No.
So basically, we
Yeah.
can't say anything about option 2.
Option 2. Yeah. That's the I mean to say. That's why I want. Differentiability says the function is, plane exists means differentiable. But there are such possibility when the function is not differentiable, but you can get such possibility, such kind of, you have like constant, continuous. You can get the tangent line a particular direction, but you cannot say exactly at that point the tangent plane is exist. And there are actually, there is in video, sir have written a theorem saying to be a sufficient condition. I haven't remember that in video, in which video lecture sir have gave a formula, a theorem for that. He didn't prove that, but said that theorem. This is in finding the tangent hyperplane, I think so. Sir have given a sufficient condition for existence of tangent plane.
Yeah, yes, sir. Suppose the gradient exists and is continuous on some open ball around the point A. Then for
Correct.
every unit vector u, the directional derivative FUA exists and equals
Correct.
gradient
The
as
partial
well.
derivative exists and continuous. Then you can say in the some open ball around a small neighborhood. Then you can say the tangent plane is exist. And yeah, actually that's the needed condition. And actually when you check for the differentiability for multivariable, if you check for differentiability of function, if both partial derivative is continuous at a particular point in a small neighborhood, then that function is continuous and something. Let me check once. Just 1 minute. What is the sufficient condition? Or you can tell me the video at which point that is.
Del F exists and is continuous on some open ball around the point A. Yeah. Then we can say that tangent plane exists.
Exists.
Yeah.
Yeah.
Mhm.
But here the constant means not saying to be, not saying here for this question. Okay.
Constant means we can't say that it is continuous.
It is continuous. Just now we see that in
Yes, sir. Yeah.
Pritam, are you getting that?
Yes, sir.
So that's why I said it can be. That's why this direction kind of partial derivative exists. Still, you are able to get the directional derivative, but you cannot say the exactly tangent plane is exist. So you can say that that line may or may not also lie in a plane.
So, sir, could you please discuss option 1 as well?
Okay. Here, okay. The tangent line exists at any point of R2 in any direction. So what is the for this then?
So it is correct answer. It's
It
marked
is correct. Okay. Okay, so tangent line is
So basically, I was thinking of
can be,
a
it can be.
scenario where f of the functional value doesn't exist. Is that possible that the functional value doesn't exist, but the partial derivatives are existing and are constant?
Yeah, for this question is it's happening, right? For this same here.
Yeah. So if that is possible, then we can't say that question one, option one is correct as well.
But
It's possible.
okay. So you are asking for all function like this. Okay.
Sir, option 4 is correct because this can be the function, and this is a polynomial function, so this is continuous. So the option 1 will also be correct because tangent in all direction at that point would exist, and if tangent exists, they will lie in single plane. So option 2 is also incorrect because do not lie in a plane because they lie on a plane. So that's why option 2 is wrong.
Okay, so
So it's a
actually Preetham is saying to be for this option is suppose the case is for value at that point is not exist. We needed a extra condition here for that.
But partial derivatives exist at every point, so the function should exist at every point. Otherwise, how will we get partial derivatives? Partial derivatives are given as c and k, right, for every point. So the function value should exist at every point. Only then we'll get partial derivatives at that point.
yes, sir. Yes, sir.
Basically, this is a very big claim to prove because we have seen a scenario just now that the partial derivatives exist, but the function is not defined at that point. We may bring in removable discontinuity, but that won't affect the existence of the partial derivatives at that point.
Yeah, actually, for this we needed some extra condition because, or we have to, it's needed some extra condition. Okay. I will check this option, first option.
Yes, sir. Plus, please do have a look at it.
Okay, sure. Okay, yeah.
Next question is question number 5 of the same activity.
Okay, so we will go to the question number 5. But before that, I want to solve the next one, which I want to be. Then I will back to your question. Okay?
Sure, sir.
So let's move to solve this question. We consider two functions here we have, and asking for the linear we have, and it is saying to be LF1 and LF2 is linear approximation of F1 and F2 at 1, -1 and 1 respectively. Then find the gradient of that linear approximation of F1 and linear approximation of F2. A dot product. Yeah, Krishna, this annotated file will be uploaded after this session. What's the answer now? Okay, as a hint, let me give you the, maybe you don't know. Let's say you have cot inverse. So derivative of this function is -1 upon 1 plus x square. This is obtained from this one, which is 1 upon 1 plus x square. So cot inverse is will be 1 upon tan inverse x. So this will be -1 and differentiability of tan inverse x. That's why it came for this one. Am I audible? Is this it's too much time is taking like that? All of you are solving, right? Is that much calculative or anything? Or you can unmute and tell the answer if it's coming to be in cot kind of something. So one thing I want to say, assuming to be the, see, cot inverse will give a answer in maybe in degree or anything. Assuming to be it as a real number, you can tell the answer if such kind is happening. If such thing is happening, like you can think this question as a in radian and work with both side in degree radian. It's don't matter how we are saying, just for the sake of to getting the numerical value, that's all. Otherwise, if you have a doubt with the degree and radian, you can both think as a for this question only, or for this time only, I am saying, you not always to think with the radian and degree are same in radian. For this question and for this at this time, you can think that for both are thinking to be a real number and do the and tell the numerical value.
So
Hmm.
is it minus 16 by 5 e to the power 4?
So minus 16 by
5 times e to the power 4.
e to the power
16, sir, 16, 1 6.
here minus 16
By 5 times e to the power 4.
Okay. Okay, so
Maybe
let's
maybe my answer may be wrong because miscalculation due to.
the thing is, I don't want to be like exact calculation. I just want to be sure with the formula and how to solve that's all. I'm also not assuming here because you can see there is a small issue with the degree and in real value, because this will give a degree angular value.
Sir, we can do like we take the gradient vector for the f1 and we take the gradient vector for f2 and we can
That's
dot
that's
product
all. Just take the let's take the gradient of that. First find the linear approximation and
and then take the dot product of the
take the output. Yeah, that's all. I don't want V to be a I want only just you need to solve this. You need to know the process. So
it is clear.
yeah, so the formula for the linear approximation is value at, let's say,
Value
this.
at f of,
Yeah, and the next one is partial derivative with respect to x.
x minus a.
Yeah, it will be x minus a. But partial derivative with
Partial
respect
derivative with respect to y times y minus b.
y minus b, and partial derivative with respect to z x at a, b, and c.
Then we take the gradient vector of this, then the
Yeah.
constant, then we will get the same thing.
Yeah, then now and this on this formula of linear approximation, take the gradient here itself. It will give, this one will be 0 and this will okay, just 1 minute. Gradient of
We'll have
this
the
one.
coefficient of x as the differentiation with respect to x.
For the first coordinate, it will become this one, and rest are will be 0.
Coefficient of y for
Yeah, this will come, and next is
coefficient of
a, b, and c. This will come. Similarly, for gradient of LF2, it will be F1. This will be all for F1. For F2, it will be the same thing will come. Let's say this is F2 here, X, A, B, C, F2, Y, A, B, and C, F3, partial derivative A, B, and C. And just take the dot product of that. That's all. It will be multiplication of these two. So only numerical part is remain. This one I want solely, no matter what the numerical value is coming for this time only, and not it will be much calculative in its same or any pages. Okay. So that's the thing in this question. No need to evaluate the whole thing. If you just write the formula and if you take the gradient of that, it only needed to evaluate this partial derivative at that point for each time. That's all, and take the dot of that. Okay. So is it clear to all of you, or and hope all of you are able to solve this? I don't know. No, there is no responses.
Yes, sir. Yes, sir.
Yes, sir, it is clear.
So let's solve one more question, then we will to be the back to with your doubt question. Like here, this is somewhat different. This contains some knowledge of linear transformation and finding to be the tangent. This question is, we have a consider a linear transformation from R3 to R3. The matrix of this T is given with respect to standard order basis. So there is no issue with the moving freely when you will see a standard order basis. We have a function fxy, this one, which is defined at x square plus y plus z, and h saying to be a tangent plane at point -1 and 1, and S is a set collection of all those points which are in tangent plane. So S is nothing but the collection writing to be the in point wise, like in point in coordinate wise. S is the collection of all points which are in that plane, lying in that plane. So what will be the image of that set with respect to the linear transformation, because T is a map from R3 to R3. All of you, you can solve this question. If you are not getting this question, please let me know. Again, I will elaborate. In this question, nothing is that you need to find the tangent plane and find the image edge of that tangent plane. That's all. What will be the image of that tangent plane with respect to the given linear transformation? For that, the matrix is given. Matrix representation with respect to a standard order basis is given. And the matrix is of diagonal, or you can say of scalar or whatever. This question is very similar to one of the graded question which will fall in, I think, week on the week of linear transformation. Find the image of in a tabular form is given. There are 4 sets or 3 sets, and matrix is also given. So you can connect with that question. This is exactly the very similar, not same, exactly very similar to that. I hope all of you are solving this. And Preetham, that first option actually will be the correct. I will tell you the argument. The reason is when we see the tangent line, existence of tangent line don't need it condition that it should be continuous or such kind of. So at all point you are able to get the value, functional value at that point, and directional derivative is already given. So in any direction you are able to evaluate the tangent line, but you cannot say the tangent plane is exist.
So what
If tangent plane not exist, if we cannot say that tangent plane exists, then the second option should be right, because second option is saying that there is not does not exist any plane.
No. So does not exist mean may not. No. So second option is saying to be that line, tangent line is not exist in a plane. No, I forgot. The condition is, let me know, if tangent line is exist in all direction, in any direction, all direction, in any direction, still you cannot say the tangent plane is exist. One
Why,
thing.
sir? Why, sir? This is
Yeah,
why.
actually, yeah, I am unable to give exact the function. You can actually counter that.
Because sir, I showed in video a graphics where all the tangents are lying in a single plane if they exist in all directions.
Yeah, it can be, but it is not a sufficient condition. If tangent plane is exist, then you can say tangent line is fine. But tangent line is exist is still in all directions. Still the problem is you cannot say that tangent plane is exist. Yeah, actually there is a function. You can counter that with the one example, but this time not getting. I will post you that sufficient
Yes, sir.
condition.
Yes, sir. I got. I little bit I'm getting, because when you draw the tangent lines, then between two tangent lines there will be some gap, but in tangent plane there is no gap between. Maybe this can be
Yeah,
the case.
actually because of the plane is saying to be a full of like a
Ah,
plane.
yes, sir. That is
So
what I was thinking. Maybe you are right, sir. Okay.
no, but that is not a reason to be gap kind of. Saying to be in all direction means that is not gap kind of. There is not a proper way to gap. Yeah, but the you can counter with that example. I will post that in discourse. This time I'm not exactly getting that example. You are able to evaluate a tangent line in all direction, but still tangent plane is not exist. And for that question, as you say, value is, see, when you are asking for the tangent line or defining at that point, so function should, you are able to evaluate, you are able to get value at all points, then you are asked for the tangent line at that point, right? So you are able to get value. So first option, that's why it's going to be correct. The second is still the second option is saying you are able to, for that question you are able to get a tangent line in all direction, but you cannot get a plane. That's why second option is not true. Yeah.
Sir, what I asked is that is there a possibility where a function is not defined at a certain point, but its derivative partial derivatives exist?
No, the function is not defined means you cannot say like function is surely when there are such question you will work in the domain, right? So there is a possibility, not possibility, you will work with the existence of the value in that domain, like saying to be in the domain, you in
Okay, sir.
domain you will ask, in
Okay,
that domain you will ask.
okay, sir.
So okay, and for a counter example I will post in discourse, surely.
Okay, sir.
For that, I have to search. Which option is going to be correct for this?
So option 4.
So actually option 4 will true. Let's see that how it's happening. Let's solve this. So we have a function, this one. You have already given this function, okay? So asking for the tangent, h is a tangent. So let's find first the tangent plane at -1 and 1. So it will be z equal to, I'm saying to be this equivalent, not denoting h as a tangent only. So z equal to value at that point, partial derivative with respect to x at that point, then x minus x plus 1 will, then partial derivative at -1 and 1, and y minus 1. This is the formula, or this is the formula for tangent plane at -1 and 1. Let's find now partial derivative at -1 and 1. So this is just a previous question. This one, if you see that here, so exactly the function is same. So and we have found here the partial derivative, which is here. You have already seen that. So the partial derivative here with respect to x, or you can say gradient at -1 and 1 will be -1 and 2. So here it will be -1, and fx fy partial derivative with respect to y at -1 will be 2. So let me see once. Yeah, it's correct here. So you have already, so it's up to you. You can calculate. So this will come. Now let's find h, tangent plane. So value at -1 and 1 also we have previously evaluated, which is 1, or directly you can check that. It will be 1 plus 1 minus 1. So it will be 1 here. So z is equal to 1 plus this one minus 1, x minus x plus 1 here, plus this is 2 here, and y minus 1. So this final thing is z equal to z equal to minus x minus 1, and here will be -1. So -1 plus 1 will cross. So final thing will be minus x plus 2y minus 1 minus 2. So if you solve this equation, you will get this this equation, which is saying to be tangent plane at -1 and 1. Now asking for image. So image with respect to t. So h we have given as s is here. So how do we find the image? The just multiplication, because here we just do the matrix multiplication. This is 0 1 0 1 0 0. With while taking a general point, you can say that this is x is as it is, y is as it is, and z is, you can z can be written as in terms of x and y. So you can write like this. And why this is enough to taking the matrix multiplication is, you have we in one session I have discussed, if you have a standard order basis, you can freely do all things. If basis is different, then you have to change. See why I'm saying this, you have to change as a point wise, right? Yes, you have to find yes. So how you will find yes? Yes will be x, y, and z is here minus this one, minus x plus 2y minus 2, such that x, y belongs to R. So image will be taking the image of a general point and do the multiplication. So final thing will be here, this will come as exactly minus x plus 2y minus 2. This will come as y and this will come as x. So you got image of this particular point, but here you can change with the x and y any value, real number, which will work because of standard order basis. Now assume to be like here the option is asking in with a relation here. So I want a relation, not as a point y here is given. So just write in the relation form in x and y and z. So what will be the how you will get a relation? So this is, you can think x, capital X coordinate, you can think this is capital Y coordinate, capital Y, and this you can think as a capital Z. So here capital X is equal to minus x plus 2y minus 2, capital Y is equal to y, and capital Z is equal to z. So exactly capital Z is equal to x. So change with the variable here, x is equal to minus x is actually capital Z plus 2 to y is capital Y minus 2. So you got the relation between like in x and y and z, but the notation is different. So final thing is writing to be so here what will be z equal to, you can send it again this side, capital Z equal to capital X plus 2y minus 2. You can change now in a small variable if you want. So you can, while changing, you can say z equal to x plus 2y minus 2. You can check that this is exactly as what you obtained for h, like here, a tangent plane, this one.
Yes, sir, that I understand. But if it is not a standard basis, then what you said about, then what would we do?
If suppose there is a difference in standard order basis, then you have to change this. You have to write the coefficient here with respect to that that ordered basis. Let me tell you. Suppose your ordered basis is for the codomain is, let's say 1 1 1 1 1 0 and 1 0 0. Okay. Suppose for codomain you have this ordered basis. So for that, see, this is written in this form is written in standard ordered basis. So you have to find the like you what you will write. The process is you have to this vector minus x plus 2y minus z. This vector you have to write in the this form, right? A time 1 1 1 plus b time 1 1 0 and c time 1 0 0. That means you will multiply with this matrix here a b c, not x y z, whatever
Okay,
you
sir.
found the coefficient.
Okay, sir, I got it.
Okay, so multiply here with the coefficient after changing in the order with respect to that order basis. Okay, so because of this standard ordered basis, it's make easy to solve, otherwise it will be difficult. Okay, so now you can ask your doubt again from your activity, or we can move to the next question also if you have your doubt.
So question number 5.
So okay, question number 5. Okay, which of the following is the tangent line passing through the point 1 minus 1 and parallel to the this line t yt and zt equal to this? So what's the issue here, Pritam?
So I haven't seen lines in this form. So and it's difficult for me to interpret it.
Line in this form.
Yes, sir. Viewing lines parallel to a parametric equation, that is difficult for me.
Okay. So actually, see, parallel is two lines. Let me tell you, two lines are parallel. Then what is the thing is, the points may be different, but the direction will be same. It can be this line to be same, means this side is both side. So direction will be the same, but the point may be different. That's the meaning to be parallel line, right? So here, see, in this for this course, for this course, for here the direction is parallel. Here this will decide you. See, you have you know that x t is equal to a time plus if the at the point a b and in direction u1 u2. Okay, so tangent tangent line of the function this one at point a b in direction of u1 u2. So it will be u1 time t, yt will be b plus u2 time t, and zt will be c plus directional derivative at in the direction. Let's say this is u at point a b t time. So actually these things decide the direction. The points may be different. Let's say I'm saying to be now the what will be the parallel line. So let's say suppose this is a prime, but the direction will be u1 t, yt will be a b prime plus this one, and let's say zt is equal to c prime, the same as here direction. See, these things are written in unit vector, so it will not, it will, these will be unique. These are all will be unique. So uniqueness is happen here. There is no issue. The points
Only constant part will differ.
Differ.
Yeah, constant part only.
Also, you have seen that in this while solving system of linear equation, two planes, or in R2, if two lines is given, let's say this is x plus y is equal to c and x plus y is equal to d. If c not equal to, then there is no solution. Why this? This means is these two are parallel. The same thing is here. You can say you can say the constant term. Constant term may differ. These two are different, but the direction is same here happening as here. And the uniqueness thing is happen because of you are taking here unit vector. So now you can go with that.
So please show the question. So basically, we have been given the point A comma B, and we know the directions are 1 comma 2 in the direction of 1 comma 2.
Correct.
We have to find the unit vector, and then we have to find the corresponding plane.
Yeah, corresponding parallel line, which for what it's for what?
Yes, sir, parallel line. Okay, sir.
Okay, so okay. If you have anyone have other doubt, then we can do. Otherwise, let's move to our what we are solving next question.
So I have one last doubt from practice assignment.
Okay, okay, Preetham. So anyone else have doubt? Then otherwise we can move to the Preetham's doubt. No. Okay. So let's see. Practice assignment.
Question number 5.
Yeah. So Z is equal to represent a surface. Let represent a surface. Okay, let Z equal to be the point where the tangent plane to the given surface is parallel to the tangent plane this. Okay, find the value of this one.
So, sir, there you said that the parallel means the unit vector would be same. And how would we do this in terms of uh, not a parametric equation but a algebraic expression?
In an algebraic equation, let yeah, till now we discussed for this line. Let's say this is happening. Let's say ax plus b plus c z is equal to d, and let's say a1 b1 c1 and d1, and this is a2x plus b2y plus c2z equal to d2. So parallel means again, as you know, these two line, when these two line will parallel, see if there is, suppose there are some constant thing is negligible, then you can, sorry, negligible means you can cross that constant, and finally you can say when these two lines will parallel means what it mean, that a1 a2 and like a1 will be, or maybe a2 will be some multiplicative of a1, let's say k time a1, b2 will be some multiple of, sorry, multiple of k, let's say d, let's say k prime of b1, and c will be c2 will be some multiple of c2 will be some multiple of, let's say, k double prime of c1. Saying to be these two line will be parallel means such thing is happening, and d2 will be d1 not equal to d2. And the case also you can add when you remove this. Okay, no issue. D1 not equal to d2. If such case is
The
happening,
k prime and k double prime will be same, na sir?
can
They
be
will
same.
the same.
That's why I want to, so suppose these are the same, then just divide those number, and then final again you will get that this equation can be changed to the a1x plus b1y plus c1z upon d prime d2 k k, let's say k. So the condition to be parallel, it can be exactly equal, or it cannot be it means it's saying to be it is exactly d1 means identity, or not solution means saying to be not exactly equal, or maybe exactly the same plane, because a line or a plane is parallel to itself. So it will be exactly d1 or not. Suppose that we are asking for different plane, suppose these two are plane, then it will happen. If identity like identical is thing, then it will be exactly the same d1.
So basically A1, A2, B1, B2, C1, C2 and D1, D2, all these are in the same ratio.
In the same ratio.
No, all are all will
D1,
not be the
D2
same
may
ratio.
not be in
D1,
the
D2, yes, D1,
D1,
D2
D2 may not be same.
D2 will be different, but yeah, A1, A2, B1, B2 and C1, C2 will be in the same ratio.
Yes.
Sir, can we solve it, sir?
Or after simplifying, we will always get A1 and A2 same, B1, B2 are will same, and C1 and C2 will also be same, and D1 and D2 will be different only after solving.
Same ratio means don't think that it will be yeah, actually the cases will different. Let's say it is like this. Let's say let me write numerically, maybe in parametric or maybe in this parameter or constant, it will be like here is difficult. Let's say like this is happening, 2x plus 3y, yeah, it will be in the same ratio, plus 3z equal to let's say 5. The next is 4x plus 6y plus 6z equal to, suppose this is 12. So
these
Yeah,
two,
actually, those will come in the same ratio. Yeah, I made a differently. Those will come in a same ratio. Yeah, numerically it will be correct. Yeah, it will be k time b1, k time c2. Sorry.
Okay, sir. Thank you, sir.
So those will be same ratio. When you divide with that constant or that multiple number, that whatever the constant term is coming, just do that, and you will get, it will be the same. The
6.
coefficients are coming the same, but it will be 6. There are two. These two are different. So what's happening that these two lines are passing from different line, but directions are same, or you can say, or here is the another word when you come to know 3D in the
This
BSc,
plane.
such kind of
This is
directional
plane.
derivative. There is a word directional derivative, proper or directional ratio. Uh, some word is proper word is in the solid geometry R3. So okay, I am not getting the exact
But these are plane, na sir? 2x.
these are the plane. Yeah.
So the normal vector will be same. We can see.
The coefficient will be in the same ratio.
Yeah, this coefficient, if we take this coefficient and form a vector like 2, 3, 3, then we'll get the normal vector of this plane, which we can say the direction of this plane in a sense.
Actually, direction, not direction. There is
normal
a proper
vector,
word.
normal vector.
I miss.
Normal vector. I'm
normal vector. Okay, yeah.
Yes. Normal
Something
vector.
that, yeah. Normal vector. Normal direction. Sorry, normal direction.
This is how we uniquely determine a plane with a point and with the normal vector of that plane. With these two things, we can uniquely determine a plane.
But this is not from apart from your course. You can link with the same from the system of linear equation. Sir have told about this is not from. You can say that this is you didn't taught solid geometry kind of. So this is in your syllabus itself. Sir have told about when the lines or plane will be parallel in week 1, 2, 3 something. So you can connect with that and can solve here.
So please scroll once. Please scroll up. So I had a doubt regarding the previous one. This F2. Please scroll up, sir.
Okay, this. Here.
Yes, this one, sir. So here you have written A prime, B prime, C prime, and here you have written U1T, U2T, and FUAB. Now, FU in the above, in the one above also you have written FUAB, and here also you have written FUAB. This will be the these two should be the equal, or this should be FU A prime B prime, or this should
no.
be
This
FUAB.
We are talking about here for the parallel lines. So these are should equal while taking the
all
unit.
The three.
This one U1.
U1 should be equal. So U1 should be equal. U2 should be also same, and FUAB
same.
should also be equal.
But the prime means these constant terms are different.
Okay. So these three terms should be same: U1, U2, and FUAB. Because the lines are parallel. That's why the U1, U2, and FUAB should be same in both the cases. But the constant may be different. A, B, C, and A prime, B prime, C prime may be different, right?
Yeah.
But sir, the tangent equation says that it has to be FU A prime B prime, isn't it?
FU A prime B prime.
If we bring in that these two are the tangent at that point.
Okay. Oh, this one you are saying. Okay. Yeah, this may differ. Yeah, actually, these only decided by U1, U2. Okay, this last term maybe differ.
But then they will not be parallel, sir. Then in that case,
no, it will be parallel.
They will not be parallel because the direction will be different. The X, Y, and Z coordinate direction will be different. Z coordinate direction will be different. X and Y coordinate direction will be same, but the Z coordinate
direction is decided by only these two, right? U1 and U2.
Okay.
Yeah, U1 and U2, right? This one is decided by the direction.
Okay.
Yeah. Sorry, I'm missing here. It may differ because of this one. but directions are decided by only these two coordinates.
Okay.
Okay, Pritam, or something you are getting
No, sir, it's okay. Actually, when you said this, you were just taking the case when two lines can be parallel. So you didn't take into account that you want the second line to be a tangent as well.
Yeah, correct.
So
Yeah.
in that case, it was correct. But now, if we want the second line to be the tangent at A prime comma B prime, we have to have that to be A prime B prime.
Yeah, correct. Yeah. Okay. So let's move to with our next question. I hope this is clear to all of you. There is no issue with this one. Okay, so let's move to the next question. That is a simple one. From a point this, in which direction the rate of change of the function is the minimum and the maximum? Rate of change going to be the gradient will be minimum. Directional derivative will be minimum, or whatever you have.
So we need to find a gradient for this function.
Gradient, and just make it unit. So maximum or minimum at a single point, asking for a single point. Let's say somebody has asked at a point A and B, the maximum rate of change and minimum rate of change in which direction will occur. So take the gradient of that function at that point, okay, and divide with the norm. Sorry, absolute value. What is that? What is the formula? I forget. I'm forgetting some formula. What is the formula?
Divided by the norm.
Divided by.
Yes, sir, just find the gradient. It will be easy. Gradient and then divided by the norm.
Divided by the norm. Oh no, positive side is minus. For maximum, it will be minus. For minimum, and for maximum, it will be
plus.
Yeah. So here is the formula. Yeah, this one. This.
So the formula will be given in the exam, or it will be, I need to remember it.
Those which are in the video lecture, I don't think so it will be given. Suppose there is some different thing, some different like needed a different formula, then it will surely given. Like that will happen. Like whatever in the video lecture, suppose video lecture have those formula, then it will not given. Suppose there is a different formula to solve this problem. It's a simple formula, it will be not difficult. Simple formula, then surely it will be given there. So this is the maximum or minimum. Taking the minus side, for minimum it will be divided with this one, and for this is for minimum, and for maximum will be the same for positive. Why did divided? Why
in the direction of -1, 0, it will be maximum.
It will be minimum.
Minus
no,
1,
it will minus
-1, 0. There.
No, here is the point. Okay. Sorry, yeah. Okay, -1 will be the maximum.
Yes.
Okay.
Direction of maximum, where the rate of change is maximum.
And why this is divided by the, again, see why this needed unit vector. See, unit vector give the uniqueness. See, suppose you have why we are dividing with this norm. The reason is, suppose you have this vector and this vector, and suppose this is our origin, and this is lying in the same plane. So this direction saying to be in this direction is, you can say with this and with this also. But when we will say when we want to unique direction, it's like unique number, like this can be also, if it will lie in the same line. So this can be saying to be a direction. So that's why for uniqueness of the direction, we need unit vector. That's why divided with the norm, you can say. It gives the uniqueness in that direction. Otherwise, you can take the multiple of that direction, and again you can say this will be the
It
direction.
is like a convention. Maybe.
Okay, so let's move to the next question here, which I have. Yeah, this one. Fifth question. If the tangent plane h at point -1 and 1 of the function itna correspond to an affine space, then which of the following is the subspace of R3 corresponding to the affine subspace?
Hello.
Yeah.
So let us solve it, sir.
Huh?
Let us do it, sir. Jointly.
Drawingly we can do. So which option is going to be true for this?
Yeah. So that I understand. So let us do it, sir. Here, all of us. Then we can.
Yeah. I given for you to solve here. So let's see that who is able to. I am giving some, let's say 1 or 2 minutes for you to solve. Then I will discuss this here itself.
I think option 2 is correct.
Okay, option 2. Somebody says option 2. Let's say.
Yes,
Anyone else?
Option 2.
So how we are getting, who had solved this? How we are getting this option is true? Option 2 is true.
Find the equation of the tangent plane. So that will be in the form of an affine subspace equal to something. Ax plus bx by plus cz is equal to d. So just remove the d.
Okay.
Just remove the d and equal to 0. That will be the subspace of R3.
So next, my question from you: why putting exactly equal to 0 will give the subspace?
Because in a subspace, 0, 0, 0 should be part of the subspace. So when you put 0, 0, 0, it should be equal to 0. That's why if you put ax plus by plus cz equal to 0, it means if you equate x is equal to y equal to 0, then you will get 0.
Okay.
0, 0, 0 should be part of the subspace, but it is not part of the affine subspace.
So there is a possibility that there can be another subspace, that corresponding subspace. I missed the word here of R3, affine subspace of R3. There can be a possibility. Let's say, suppose we have a subspace A. Affine subspace A. So there could be 2 corresponding subspace, or there would be, or there
but
is
parallel to that there will be only one subspace.
Yeah, actually there is only one subspace uniqueness, because the corresponding subspace is unique. So there cannot be 2. So it have a unique corresponding subspace of that affine subspace.
Subspace corresponding to that affine subspace. So corresponding to one affine subspace, there will be only one subspace, because subspace corresponding to an affine subspace is unique. The vector may change, but the corresponding subspace will be the same.
Okay. So yeah. So let's solve this. So what is the here? H is saying to be think as a affine subspace of R3. I missed that word here. I just now wrote here. Affine subspace of R3. So what will be the tangent plane at -1 and 1? At -1 and 1. So we have already calculated. What is that? Z equal to
Z plus x minus 2y equal to minus 2.
Plus x
minus 2y.
Minus 2y equal to minus 2.
Minus 2.
Equal to minus 2.
So this is the tangent plane at -1 and 1. Okay. Now you know that already it's given also, think as at affine subspace. And in the video lecture of affine subspace, affine subspaces of R3 is, it can be any plane, it can be any line, or it can be 0 and R3. So and anything else which can be the affine subspace of R3?
Point.
All lines are points can be affine. Points can be affine subspace of R3. All lines are affine subspace of R3. All planes are affine subspace of R3. So
And R3 itself.
and R3 and origin also can be itself affine subspace of R3. So now you have this plane, so you can think as a set. Here also given as this is affine subspace. So let's say this A equal to x, y is set such that this condition is followed. X plus z, x minus 2y plus z equal to minus 2. So now affine subspace of R3, any plane could be, let's say this is the plane. So in video lecture sir have said if you want to find the that subspace, just put 0, and in the video lecture
We
sir
can
have
say
said
that to get the subspace, we
you
can take
put
a
the
plane parallel to this, which is passing through origin.
so actually you can get the plane which pass through origin in that,
and should be parallel to this plane.
In parallel to this plane. So parallel to these planes means, as just now we discussed, the coefficients of the these are the same. So and passing through origin means it will surely give 0. Okay, here is minus 2. So corresponding subspace will be the same, that plane which says to be the parallel, and next is put 0 to. So that's the thing corresponding to the subspace corresponding to that affine subspace. So all of you got this point. If you have doubt, you can ask here, and if you have doubt from activity or practice from anywhere, you can also ask. Otherwise we will solve the last one question. Let's see that here. So this is very similar to the practice one which we just now discussed, parallel to this plane, at which point tangent plane is parallel to this plane. Which of the following points are satisfying the function this, where the tangent planes are parallel to the plane this?
Second option only.
Second option. Okay, anyone else getting different? Let's say I'm writing here option 2. Anyone else getting different?
So do we have to check for all 4 points?
Yeah, you can check. It's up to you. Or one option you can easily check that the first thing is how we neglect this options by an option. So you can see that first option easily can neglect, while this is not point from the for that function, not satisfying that function. Rest 2, 3, and 4, if it is satisfying, then the next process, how you will check or how you will get that.
Okay.
So I wrote is R. So you can think that there are a possibility which have represent the same plane. Suppose graph is like this. So tangent plane may be for the single plane, it may be for the 2 points. So that's why is R I have written is /R. So points can be different, but the whatever you got tangent plane, it will be parallel to the whatever asking. So that's why it may be maybe option two is somebody says, and maybe 3 also, maybe 4 also.
I think
One
4
is
is the right answer. 4 is right answer.
4. Okay.
Others are not correct. 4 is right, I think.
Okay, only 4 you are saying.
Yes.
Let's see that. Only 2. Atul is saying only option 2 is correct.
Yes, sir.
Yeah, actually there are the process is to solve you can go with the best thing is
we can find the plane, tangent plane, the direction of the tangent plane, which is the gradient vector.
Gradient vector.
Secondly, gradient function at which point this is satisfying. We have to check. We can get the gradient function first.
Yeah.
And
So
then
take the gradient. It will be 2x minus 2y, and gradient at each time if you want to check. Let's say let's evaluate that first very quickly. It will not take time for you to. If you check that, the first thing is which points are lying or satisfying this function. So you can check that all 2, 3, and 4 are satisfying that, and very quickly you can see that it can be just evaluate the gradient at each point. So only needed these two because the fourth one is saying to be the z value, z axis. So only these two are. So let's evaluate that. It will be -1 and -1 for the first one, and okay, for the second one it will be 4 and 4. Okay, for del f at this one is it will be again -4 and -4.
So if we express this plane in, if we take the z on the other side and keep the x and y in one at the single left hand side, then we'll get -x, -y, and -x, -y.
So you take an my approach is you take an arbitrary point AB and then find the tangent plane at that
correct. That is also a good way. Just take arbitrary point. So whatever each time you can find, and the z is equal to, or maybe x, y, and z. Let's say each time you find ax plus by plus cz plus equal to d, and just make it there is no multiple of that, because here you can see there is no multiple. Just make it as a you can think as a unit, kind of make it just unit, and just compare what's happening If these two are same and or making different, then you can read it is parallel or whatever. No, it is parallel or not. So
Sir,
that's
but we can also do that like z is equal to minus x minus y plus 1. This is the plane we have given. So we can compare that x and y coordinate have the -1 coefficient. So which
yeah,
we are
actually
only getting in option 2.
just be sure that your
Yeah, in same form,
not
which we
like
are in which
-1,
form we are getting
-5,
the tangent plane.
yeah, whatever you constant able to divide, just make a unit kind of just divide that constant and then compare. That's the mean I want to say. After
Yeah,
dividing the that constant and then compare. Okay, so that's for today. If you have doubt, you can ask.
So one basic query over here.
Mhm.
Yeah, why are we taking this random things like -1, -1, 4, 4, and -4, -4?
Not, I am not taking random. I substituted values for each time. This not I'm not taking random. First I took gradient, and for first one I evaluated this one. For second one, for third one I evaluated this.
Okay, got it. Thanks.
So what is the answer to this?
So what's the offset is going to be, or second? I didn't check. What's the option 2? Many of you.
Only two.
Fourth is a right, sir.
Only
Fourth.
No, sir.
Fourth is right.
Fourth is right, or 2 is right. What's happening? This is just Riemann calculation. Calculation is what's happening. That's all.
So
Sir,
basically the gradient part that is giving me the coefficient of x and y in the equation of the tangent plane, right? So then on the left side we usually have z, and z has coefficient 1 if we put it in the left side. Suppose I'm bringing it to the right side, it becomes -1. Now the ratio of -1 and the given plane is -1.
Yes.
Sir?
Sorry, sorry. How are you saying? You are writing like this: -z equal to.
So I'm taking everything to the left side.
Everything to be the left side. Okay.
Yes, sir. So what I get is, say suppose
2x 2x
is
minus 2bx minus z equal to a square plus b square plus 4. Is this the equation you are getting? 2ax minus 2bx minus z equal to a square plus b square plus 4.
See, my thing is, see what is that I am saying. Just each time find the equation of the tangent plane, and hope you know. See, you know that how to solve this system of equation, and how when we will say that system has unique solution or no solution. If no solution is happening, then you can say that is parallel. If infinitely many solutions is happening, then you can say still it is a parallel. Infinitely many solution is means saying to be exactly the same. And if it is unique solution, then it is intersecting. Otherwise, suppose infinitely many solution and no solution is happening, then you can say it is parallel.
Sir, can I ask can I ask a doubt?
Pritam, you got my point.
So basically, I think you should attend who is asking the doubt now, and I would want you to confirm whether my the way I'm solving it, is it correct or not.
So we have to check only coefficient of x, y, z, which should be 1, and the right hand side should be any constant. Then we can say that it is parallel. No?
Still, if you have, while checking the constant, it is, if you have doubt, then just find the tangent plane and check the solution. On the basis of solution, you can decide if it is infinitely or no solution. Then you can say these two are parallel. Otherwise, unique solution is happening, then they are intersecting. That's all. That's the.
Okay. Sir, can I tell my solution?
Okay.
Wow.
So,
Okay.
First we find the doubt. First we
okay, whatever your way is that, let's leave it that. Just checking. See, each time if you are, this is a If you are getting you are getting with a long process, like finding the each time and deciding, or with the getting the solution and deciding, that's the up to you. Yeah, but you can decide the two lines are parallel, or sorry, two planes are parallel with the saying to be infinitely many solution or no solution. That's the thing. So let's to be
Yes,
one
sir.
have doubt. Okay.
Okay, sir. The way I understand the problem is there's I have to draw a tangent from a plane, right? So can you just scroll up a bit? So which of the following points is satisfying the point where the tangent planes are parallel to the plane, right? So when this is parallel, x plus y plus z, if I that's a like a scalar vector, then I'm taking the gradient of it. Then I have the direction of this, and I'll put this in place of fxy. And whichever points are satisfying that, my points are satisfying this entire thing, right?
Okay. Okay. So again, I will say, okay, it's up to you how you are solving. Say my. Let me tell you
No, sir. I'm not saying there is any other way to solve. This is the only way to solve. That is the why. This is the ambiguity here. I'm not saying this is like another way of solving. It's the only way of solving.
Okay, so what is the process? See, each time we have found the gradient. Okay, let me solve that. Okay.
No, sir. Can I just define which one is plane and which one is line and what we are trying to do? Maybe before that. So first of all, fxy, right? Fxy will be a line, right?
Fxy.
Yeah. Function of x and y is a line, right?
Function of x. This one.
Yeah. It's a line, right?
No, this is not. No, this is not a line.
This is a surface.
This is a surface. This is not a line. So a line means saying to be in like in R2 or in R3. Line means that's why the symmetric equation like this one. Let me show you. Or this one. This kind of symmetric equation or parametric equation. It will not give you a relation between x and y and z. So like it will retain in a separate form where t is as a parameter will work. So this is a surface.
So when we write a function, right, it can be like a function of a line, a function of let's say a plane and also a volume also, right? So how we know that? By taking a span of that, right? So if I say like span of this vector, let's say in this region, then that will be either a plane or a volume or like that, right? So in span means like taking like double integration or triple integration, doing surface integral or that, right?
Span means suppose you are taking a span of this single vector. So this will represent a line. Okay.
Yes, right.
If you taking a span of two vector, like independent mean it will not a multiple of the.
Yeah, then it will span
a span of that is a plane.
Plane, right?
Yeah,
that's what I'm saying. So
and suppose there are three, then it will represent the whole R3.
Okay, so and I'm thinking if it's a tangent planes are parallel to the plane xyz. Okay, so if I extract the direction from this plane, which is denoted by x plus y plus z, right? If I and put like do the gradient of it, take the gradient of it and equate it with fxy.
Okay.
I'll get the same thing, no? I'll get the points which are satisfying this equation, right?
Take the gradient and
take the gradient of the plane. I mean, take the vector form of
it will be
whatever
1,
it is.
1. Okay. And it should gradient of that plane. It should be.
It should satisfy the function that is fxy, right?
No.
That is how we get tangent, right?
No.
The tangent plane in the direction of
gradient gives the direction. It may not be lie in that function. It gives the direction.
I'm saying a point which lies in fxy in the direction of gradient.
In the direction of gradient. Okay.
And when we add the gradient part automatically, okay,
Mhm.
that becomes a vector, and it can be like a space, a line, volume, anything. So we can directly supplement instead of like take the gradient and equate it to fxy. That's what I'm saying. So if there's a okay, so if there's a point I want to find in a line, let's say x plus y equals to 1, or x square plus y square equals to 1 maybe, which is a line of a circle. And if I want to find if, let's say, point A and B satisfies is in that circle or not, right? In that xy boundary or not, what will I do? I'll put x as A, y as B, and check, right, whether that is satisfying or not.
Yeah.
Is a square plus b square equals to 1? Then I can say that xy is in that
AB in
equation.
that.
Equation, yeah. So that line I'm saying. Okay, and exactly here that is what is happening. If x square minus y square equals to 4, right?
X
Then
square minus y square is equal to 4.
Yeah, right.
Why you are putting x square minus
If
y
xy is 0 at the center, x square plus y square equals to 4.
Okay, okay. If you add center, okay.
X square minus y square equals to 4. So there's a like
At
x
center.
plus iy.
No, I didn't get at mean by the center. This is not passing through.
I'm taking everything in geometrically, right? So 0, 0 will have a x, y, z coordinate, right? 0, 0, comma 0 is x0, y0, right?
Okay.
Yeah.
So
and if I put it there, 0, 0 is x square minus y square equals to 4, right? So that is a x plus iy.
4.
X plus iy circle, right?
Okay.
This is a x plus iy cycle, right, sir?
X plus iy.
This is the circle, right? X square minus I square, y square.
What is I here?
So I is the imaginary number, right?
Oh, no. So don't go with this. So,
I'm not. I'm just saying like this.
And still this may not be a circle in the imaginary. Please.
X plus iy is a unit circle. No? I mean, if x is unit, then
no. So don't go with the imaginary part. Okay, in the imaginary, in complex.
Okay. I'm not going. Okay, fine.
Complex.
So if I, I'm not going there. So I'm
what
saying
you want to tell you? What you want to tell you? I am not getting.
So I'm saying if I want to find a tangent to this plane, okay, which is parallel to the plane x plus y plus z.
Okay.
When I know parallel, I mean direction is preserving, right? And how will I get the direction? By taking from a scalar. See, this is a scalar. There is no direction in this plane, right? So how will I get the direction from it? By taking the gradient. Okay. So now I have direction. Okay. Now I want to find the point to draw that tangent on, right? And that point must lie on fxy.
Okay.
And each of these vectors is a combination of like direction plus the component of it, right? Like x or y or z, right? Linear component of it. So once I have the direction and I have to find the value of it, then I'll just equate, right? And if I do that, then I should have the tangent direction. And plane I can construct by expand. See, this vector option A, B, or C, or D, nothing represents a like a plane, right? Once I expand this, then it's a plane, like a span of that vector, right?
Okay.
A vector, only a point, right?
Okay. So okay. So we are solving it geometrically. Yeah, actually, yeah, whatever your direction is saying, see, that is called the normal direction of that plane. Normal ratio something, or normal ratio something is called. Yeah, this can be solved with the geometrically also with the normal ratio something word, and you can I haven't remembered that formula. If you have normal ratio and you have, if you have a point, you can find the tangent plane or that plane. So okay, yeah, that's fine. There is a formula something writing to be normal ratio. If you have a normal direction, normal ratio, normal direction, let's say A, B, and C, then the equation of the plane can be written ax plus by plus cz equal to d. And suppose is passing through the point 1, 2, 1, 1, 2, then put in value and get the value of d, and that will be the equation of the plane. Okay, so that is another thing.
Like x minus a divided by the component plus y minus b divided by the let's say a, b, c, d. then that x minus a that is happening, that is the scaling of x part, right?
Okay. Yeah. Okay. Whatever you are saying. Okay. Okay.
I'm just saying, like I can do this, right? Like I know I'm limited to 3D. I can't move beyond that, but I can do it at least 3D in this way, right?
Yeah. Okay. So otherwise, the simple process is each time just find the tangent plane, and you can check with the it is equal to or it's having unique or infinitely or no solution, and you go with that and you can decide. Yeah. No matter. So okay, Pritam, you want to ask something, or let's end the session? It's about 11:45.
So I was saying that suppose A comma B comma C be the required point.
Okay.
Right. Then we are gradient we are getting the gradient as 2x minus 2y, right? So 2e will give me the quotient of x in the equation of the hyperplane.
Yeah. Yeah.
And minus 2b will give me the quotient for y.
Yeah.
And the quotient of z, if I take it to the right side, that will be minus 1.
Okay, minus 1. Okay.
Then now we have to divide this by the quotients of the given plane, that is 1, 1, 1.
Okay.
Then we get our a and b, and then after we put a and b in the function, we'll get z.
Okay. Okay.
So this was what I am saying, and is it correct or not?
Okay. Okay. Yeah, but when you put here a and b will come, and how then the problem is, then you have to check which one is satisfying. Okay.
So here
putting the value.
We are getting a unique solution, because see what is happening is b is minus half, because 2a equals minus 2b equals minus 1. That is what we are getting.
Okay.
So a equals minus half, b equals half, and once a and b and
you got then z will be the substituting. Okay. Yeah.
So option 2 is correct.
Okay. So okay, let's end the session. And I don't know, many of I am tried to solve many of your doubts. In last there are some, I also I am trying to understand your words, but I didn't. Like almost I got, but in last sometime I missed that. So it's your approach. You can solve with the solid geometry kind of thing, or you can solve it here also using the linear equation system.
So what is the correct answer, sir, for this?
So yeah, option 2 is correct. Option 2 is only correct. Option 4, you can, if you check that, it will missing something, some number. That's why it's option 4 is not correct. Or let's we have done for the till here. So what will be here the equation of the tangent for option 4? It will be minus 4 x minus 2, and minus 4 again will come for y minus 2, and value at minus 2 and 2. It will be minus 2 and 2. It will be minus 4. Okay, it is satisfying minus 4 minus 4, and minus 4 is here, so which is 4. Sorry, minus 4 is here, value is coming minus 4. Sorry, this one and this one will cancel, minus 4 will come, so this is minus 4. So z equal to minus 4x.
So that will be x plus 2.
X plus 2.
Yes, sir. Because
sorry, x plus, sorry, x plus 2. So this will be minus 8, and this is minus 4 here, so minus 4y plus 8, and this is minus 4. So this will cancel out. So z is equal to minus 4x minus 4y minus 4. It's coming. So let's move a single side, one side only, and we try to remove the constant if it's there. So it will be 4x plus 4y plus z, and right side let's leave it with the constant minus 4. Now you can check that there is no constant. There is no constant. Okay. There is no constant to cross it, and you have this one. Oh, I said one missing thing. Infinitely many solution word, that is not here. Only no solution will happen. The cases for a parallel is no solution. Okay, I missed that. Only no solution will happen, then these two lines will be parallel. So if such case is happening, we have x plus y plus z is equal to here 1. So if you solve this, if no solution is here, then you can say these two lines are parallel. Otherwise, so it have no solution. This system of linear equation has infinitely many solutions. Okay, so that's why this is going to be this is not going to be the parallel. One thing I missed that it should be only the case is no solution. Yeah, I forgot that the case is no, for the no solution, the lines and the planes will be parallel. Otherwise, for infinitely many solution, it will cross. The reason is, suppose infinitely many solution is then two planes are intersecting in a line, like in a line like this. Suppose this is, and this is the case, like in a line. So it can be infinitely many solution. Okay. So for the parallel, there should be no solution. Then these two lines will be parallel. Okay. Is it clear to all of you? No.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay. So let's end the session. Thank you so much. And today is also Holi. So happy Holi to all of you. Okay, bye. Have a nice day. Yeah. Thank you so much.
Yeah.